also known as a clock cycle or a CPU cycle, is the time it takes for a CPU (central processing unit) to complete one cycle of executing instructions. This includes the movement of data between registers, the arithmetic logic unit, and memory. It is the basic unit of time for a CPU's operations. In simpler terms, it's the duration of one cycle in which the CPU can perform a particular operation, like fetching, decoding, or executing an instruction. Factors affecting CPU performance: clock speed. The frequency of the clock signal determines how many cycles can occur in a second. Higher clock speed generally leads to better performance. The clock speed is measured in gigahertz, indicates how many cycles per second the CPU can perform. For example, a CPU with a clock speed of 3.0 GHz can perform 3 billion cycles per second. Higher clock speed generally allow for faster processing of instructions. Pipelining. The efficiency of pipelining can affect how well multiple instructions are overlapped. If the data path cycle is optimized for pipelining, it can significantly enhance performance. Modern CPU often use pipelining, where multiple instruction phases (fetch, decode, execute) overlap in execution. A faster clock speed can enhance the efficiency of this process. For example, if a CPU can complete one instruction every clock cycle due to pipelining, a higher clock speed will mean more instructions are completed in a short period. Data path width. Data path width refers to the number of bits that can be processed simultaneously by a CPU's data path. It's essentially the width of the highway that data travels on within the CPU. A wider data path allows more data to be processed simultaneously, which can reduce the number of cycles needed for operations. Here are some ways a wider data path can improve performance. Increase throughput. A wider path A wider data path enables the CPU to process more data in parallel, increasing the overall throughput. Reduce cycle count. By processing more data simultaneously, the CPU can reduce the number of cycles needed to complete an operation. Memory access speed. Memory access speed refers to the time it takes for a CPU to read data from or write data to the system memory (RAM). This speed is measured in terms of latency, which is the time it takes to access a memory location, and the bandwidth, the amount of data that can be transferred per unit of time. The speed at which data can be read from or written to memory affects the overall performance, as lower memory can create bottlenecks in the data path. Here are some reasons why memory access speed is important. 1. Instruction execution. The CPU needs to access memory to retrieve instructions and data. Slower memory access speeds can delay instructions execution, leading to reduced CPU performance. Data transfer. Memory access speed affects the rate at which data can be transferred between different parts of the system. Faster memory access speed enables faster data transfer, which essentially for applications that requires high speed data processing. The end.